and welcome back. I am Mukul Wani, the Secretary of IEEE SISGST, and I am thrilled to host the episode 2 of our technical series. In our previous episode, we laid down some foundational concepts, but today we are diving into the heart of modern embedded systems, the microcontroller. But what exactly is a microcontroller? Think of it as a tiny, self contained computer on a single chip, unlike the laptop or PC you might be watching this on, which is designed to do million different tasks. A microcontroller is built to do specific tasks incredibly well, like reading a sensor, controlling a motor, or managing smart home devices. Today, we are going to explore the most popular and beginner friendly microcontroller platform, the Arduino UNO. We have talked about powerful microcontroller like a feature-rich board like the ESP32. They are fantastic for complex applications, but sometimes the best way to learn and experiment is with simplicity. The Arduino UNO truly shines here. Its design philosophy emphasizes ease of use and accessibility. It comes with an onboard LED connected to digital pin 13, which is perfect for visual feedback without needing any extra wiring. This makes it an ideal platform for beginners to grasp fundamental programming concepts and microcontroller interactions. Using just the board and the USB cable, it allows us to focus purely on the code and logic rather than getting bogged down with circuit assembly. Now, let's quickly revisit the key features of our Arduino UNO R3 that we'll be utilizing for this project. At its core is the Atmega 328P microcontroller. The USB-B port is a lifeline, providing power and allowing us to upload our code. As you can see, this end we will connect over here for USB-B port, and the another end is USB, which will be connecting to the laptop or PC you're using it on, which is crucial for today's project. We have the onboard LED, which is usually connected to digital pin 13. This LED is our primary output for our project. We also have the reset button, which can reset our program for input. While we won't be using external buttons, we can always use the serial monitor for user interaction, which communicates over the same USB connection. The Arduino UNO R3 is built around the Atmega 328P microcontroller, an 8-bit AVR processor. This microcontroller operates at a clock speed of 16 MHz, driven by a ceramic resonator, allowing it to execute approximately around 16 million instructions per second. The board's operating voltage is 5 volt. It can be given through USB Type B port, or it can also be given through battery, which dictates the logic level for its digital pins, meaning they output 5 volt when set to high. For memory, the Atmega 328P includes 32 KB of flash memory for storing your program code, with 0.5 KB reserved for the bootloader, 2 KB of SRAM for dynamic data and variables during program execution, and 1 KB of EEPROM for storing data that needs to persist even when the power is off. The Arduino UNO R3 offers extensive input-output capabilities, featuring 14 digital input-output pins, numbered 0 to 13, which can be used for reading digital inputs like buttons or controlling digital outputs such as LEDs. Among these 6 pins, 3, 5, 6, 9, 10, and 11 are capable of pulse width modulation, also called as PWM, allowing for analog-like output. Additionally, there are 6 analog input pins, named as A0 to A5, which utilizes a 10-bit analog to digital converter ADC to read variable voltage levels between 0 volt and 5 volt from sensors. Each input-output pin is designed to safely supply or sink a recommended 20 milliampere of DC current with an absolute maximum limit of 40 milliampere. So let's dive deeper into our project demonstration for Arduino UNO. We will demonstrate a small project which is known as Morse code using Arduino UNO. So what is a Morse code? A Morse code is a method of encoding text characters as sequences of two different signal durations called dots, short signals, and dashes, long signals. For our project, we will be flashing the universal distress signal SOS, which is known as help. SOS in Morse code is represented as 3 times dot, 3 times dash, and 3 times dots. Each dot is a short flash, and each dash is 3 times as long as a dot. There also are specific pauses between elements, letters, and words. We will be implementing this using simple digital write commands to turn the LED on and off, and delay function to control the timing. So let's start with the fun part. As the previous episode 1, Aditya has explained you how to download Arduino IDE on your laptop or PC. So now we will start with a demonstration of a simple project. So I have taken one simple project of LED on for 1 second and off for 1 second. So here we are assigning pin 13, which is of LED, as an output pin in the setup section. Then in the loop section, we are assigning the LED should be on for 1 second, then off for 1 second. So this will create a loop. Means 1 second the LED will be on, the another second it will be off. So as we have seen the Arduino UNO is selected, we will upload the code. As you can see, the code has been uploaded successfully. So let's move on towards our topic, the Morse code design using Arduino IDE. This is the code which we will be using for our project demonstration. We are using two variables, LED underscore pin and dot underscore duration for our project demonstration. The LED underscore pin equal to 13 tells the board to use the onboard LED which is connected to digital pin 13. The dot underscore duration tells the board to give a 100 millisecond pause with every Morse code dot. Then the setup part. The setup part instructs the board to use the particular components on the board. In our case, we are using LED underscore pin. The loop part. First, we will move on to the helper functions. So we have used three helper functions: void Morse pause, void Morse letter pause, and void Morse word pause. So what does Morse pause does? Morse pause gives a short pause between elements within a letter, means SOS. There should be gap between the letters. And afterwards we have used Morse letter pause. So between each letter, means between SO or OS, there should be a gap which should be more than the dot duration. So for our case we have used into 3. You can change this number. Then we have used Morse word pause. So between a single sauce and another sauce, there should be a different gap which should be greater than letter pause also. So we have used into 20 dot duration. Then we will move on to the loop part for each letter. We have used 3 dot functions for telling S, we have used 3 dash functions for O, and we have used 3 dot functions for S again. And you can see in the third line of each letter we have used Morse letter pause, which tells the duration of the letter pause, means after S there should be a greater pause. After O, there should be a greater pause, and after S, there should be a word pause. Means after a single sauce, there should be another sauce. So the duration should be increased between both sauce signal. Then for Morse dot, we have used LED pin high, then delay dot duration. Means for a single dot, we are assigning the loop. Then for the dash also we are using the same. Instead, we are keeping the dash duration 3 times a dot. As I have explained in the previous section, the dash duration should be increased than dot duration. So let's compile and run this code. As you can see, the code has been uploaded successfully, and you can see the Arduino IDE board is successfully giving source signal. And that's a wrap for our episode 2. We have explored the fantastic Arduino UNO and understood why it's the perfect platform for beginners, set up our own Arduino IDE, and built a small simple project. This project is just a stepping stone. With the Arduino IDE, your imagination is only the time limit. In our next episode, we will dwell into more further fun technical concepts. Thank you for watching. I am Mukul Vani from IEEE SISGST.